The next transformation is interaction transformation. So you have two independent variables, and you can have these squared terms if you like. Then the interaction is measured by the product of x sub 1 and x sub 2. So this is the interaction part. So we'll talk more about what interaction means, what is the significance of interaction when we look at the example. So this is the full interaction model where each variable has the first order, that is x sub 1 and x sub 2, then second order, that is x sub 1 squared and x sub 2 squared, and then the interaction term. The second order is optional. You can have it or you don't have to have it. You can go straight from the first order to the interaction, which is what we're going to do in this example. Here, this example is from your textbook. This is a personal care product manufacturer, shampoo products, and the company believes that there are two factors that influence the sales. So that is, the two factors are the selling price and then the advertising expenditure. So the company collected sales data with sales price set at $2, $2.50, and $3. And then they were paired with advertising expenditure of 50,000 and 100,000. And these combinations were tested in 24 test markets, and the sales data was collected. So let's go to Excel now and look at how interaction works. So here is the problem. The dependent variable is sales. The first independent variable is price per unit, and the second independent variable is advertising expenditure in $1,000. Sales in 1,000 units, price per unit, advertising expense $1,000. So our model here is Z sub 1 is x sub 1, Z sub 2 is x sub 2. Now Z sub 3 is the product of x sub 1 and x sub 2, the interaction term. So we are skipping the second order. We are going from the first order directly to the interaction. So we have the y values, we have the x sub 1 and x sub 2 from the sample. Now we have to set up the transformed x sub 1 times x sub 2, the interaction term column. So take x sub 1, multiply by x sub 2. Now copy that. And then we need to run the regression command. Go to regression. The y range is sales. The x range is x sub 1, x sub 2, and x sub 1 times x sub 2. 3 columns. Labels, and the output range, let's put the output range here. So let's do some formatting. So here are the coefficients. Look at the y hat estimate equation. Minus 275.8, that's your b sub 0, and 175 times x sub 1, 19.7 times x sub 2, and then minus 6.1 x sub 1 times x sub 2. So we can now use this to predict sales. Suppose if we want to set unit price as $2.75, and we want to spend 75,000 in advertising, and since advertising is in thousands, we have to enter 75, then x sub 1 times x sub 2, then we do the y hat. Y hat is, it's b sub 0 plus b sub 1 times x sub 1 plus B sub 2 times X sub 2 plus B sub 3 times the product, the interaction term. And that is, say, y hat, and remember y hat is in thousands, so predicted sales is that times 1000. So this is our forecast. Now let's look at how the interaction effect actually works. So here we want to set up the y hat values. Okay, so we are now developing estimates. This is for prices going from $2 to $53 and advertising expense 50,000 and 100,000. So first thing to do is to convert advertising expense to X sub 2 values. These are in thousands, so this is 50 and this is 100. Now let's set up the y hats. So we have B sub 0, and we need to absolute reference this so we can copy properly, plus B sub 1, absolute reference that, times the price. So price is right here, and we need to absolute reference this properly. So we need to allow the columns to change but rows to not change. So it should be that plus B sub 2, that should be absolute referenced, times X sub 2. Here column should remain fixed, row should be allowed to change. It should be like that. Plus B sub 3, absolute reference that, times, now we have to multiply X sub 1 and X sub 2. So X sub 1, and this should be absolute reference with row fixed, times X sub 2, this should be absolute reference with column fixed. Okay, now that's the predicted equation. And these are in thousands. Now that gives us the estimate for each of the prices when the advertising expense goes up from 50,000 to 100,000. So what happens to the sales? Sales goes up to 826 from 450 when advertising goes up from 50,000 to 100,000. When you increase advertising, sales goes up by 376,000 at a price when the unit price is $2. Copy that, and you see that the increase in sales as the price increases, okay, it becomes smaller and smaller with the advertising going up from 50 to 100,000. In other words, when the advertising goes up from 50,000 to 100,000, the increase in sales, the benefit that we receive, declines as we increase the price. So let's write that down here. By increasing the advertising from 50K to 100K, decreases as the price increases from $2 to $3. In other words, the effectiveness of advertising decreases as the price increases.